All right, being clever, right? I should say like, wait a minute, the last one, we just determined that if you're on a hill with no friction, your acceleration is g sine theta down the hill. Yes, does that make sense? So then, I can say since v0 is 0, I can find v final, no worries, right? Because I say v final squared is equal to v initial squared plus 2ax. So in this case, v final is going to be the square root of, so it's 2g sine theta d. That's okay. Well, that's fine. I could have made a mistake, so let's actually do the here, and there. Fn. This is fg cos theta. This is fg sine theta. See, whether we look up a hill or down a hill, does that change gravity? No. So it doesn't care which way we're looking or perceiving. And now this becomes my initial velocity, doesn't it? Do you see that? My final velocity here becomes my initial velocity for this piece. My final velocity over here. So this is like V02, this is VF2, that's 0. Does that make sense? Because you're going to come to a stop. So once again, but now because I have friction, I have to do this. Right? So then that's Fg and this is Ff. So the sum of the forces in the x is equal to ma. So that's going to be Ff, right? Negative Ff equals ma. F, what did we just say in the last one it was? Yeah, mu. That equals ma. From the y direction, we know that Fn is equal to mg. So I get negative mu mg equals ma. Cancel, and I get a is negative mu g. So once again, initial velocity, final velocity, distance. I want to find the distance, so I say v f squared equals v0 squared plus 2ax. My vf is 0, so I get v0 squared negative 2ax. Well, negative 2 because and then a is negative mu g, and then x is what I'm looking for. So I can solve all of this for x, right? So I say x is equal to v0 squared over, that makes it positive 2 answer. Questions? So, if you do not know how to do these two problems, you have homework, right? Because you need to practice these problems tonight. Because the test is going to have two problems like this. It's pretty far away. Because we have to do momentum and energy before we do that. So this is enough for these. We're actually going to move on to something else.